Welcome to week 3. On this video, I'm only going to cover the first half of this week, which is on chapter 8.3, multiplying polynomials. Now you'll remember last week we already did some multiplying with polynomials on a problem that looked kind of like this, where there is one term outside that must be distributed to 2 or 3 terms on the inside of parentheses. So when this happens, I take the one term that's outside and I distribute it to both of these terms. Now in doing so, it's very important that I use exponent rules. So 6v times 2v, we start with the big numbers. 6 times 2 is 12. And then we have v times v. Now remember that when a variable does not have an exponent, there is an imaginary 1 there. So this is really v to the first times v to the first. We add those exponents together and get v squared, or v to the second. Now I also have to distribute or multiply this 6v times the other term in the parentheses, which is a 3. So 6 times 3 is positive 18. I'm going to put plus 18. And then I've got a v here as well. This one does not have a v. That's okay. That just means that the v stays the same. So that is an example of something we might have seen last week. This week is similar, except now you'll notice we are multiplying two sets of parentheses that both have multiple terms inside them. So I have to multiply this parentheses by that parentheses, and I like to call this double distribute because I need to take both of the things in this set of parentheses and distribute them to both of the things in this set of parentheses. So I will underline the first term in my first set of parentheses and distribute it to the other parentheses like usual. For right now, we're just kind of ignoring this 8 and pretending that we're just distributing the x to this set of parentheses. So just like up here, x times x we know is x squared because of those exponent rules, and x times negative 3 is just negative 3x. Now I've finished this x. I've distributed it to everything I needed to, so it is done. You can kind of mark it off if that helps you remember. I now need to take this 8, and I also need to distribute it to everything in the other parentheses. So we're pretending that the x isn't there. Now it looks just like that problem did. 8 being distributed to a set of parentheses. Positive 8 times x is plus 8x. And positive 8 times negative 3 is negative 24, or minus 24. So I have now distributed everything. I had 2 terms in here, 2 terms in there. I've multiplied all of them. I now have 4 terms. However, at this point, it's very important I look over all of them and find ones that can be combined, that are like terms. Now remember that a like term has to have the same variables and the same exponents. So here, negative 3x and positive 8x, they both have an x for the variable. The x's both have that imaginary 1 as their exponent. So these two are like terms. That one is not a like term because it has a 2 in the exponent, which is different than these. So this piece right here has no like terms. It can stay exactly the same. Negative 3x and positive 8x are like terms, so I'm going to add them. Negative 3 plus 8 is positive 5, and the x part does not change when you're adding or subtracting. Kind of like if I say 3 apples plus 5 apples is 8 apples. The word apples didn't change, just the numbers. So negative 3x plus 8x is 5x. And then we also have this minus 24. It doesn't have any like terms, so it will stay the same as well. I now have x squared plus 5x minus 24. That is an example of double distributing. Now, of course, some of these problems might have bigger numbers or more terms. For instance, I might see something like this, where there are numbers in front of the variables. You might even see one where there's an exponent in there. Okay, that's fine. So I have 8p squared minus 2, this is in parentheses, times 6p plus 2, also in parentheses. Again, this means I need to double distribute. So I take this 8p squared, and I'm going to multiply it by 6p, and then also by 2. So to start off with, 8p squared times 6p, 8 times 6. My calculator stopped working, and so did my brain. 2 sixes is 12, so 4 is 24, so 8 is 48. Okay, 48 is 8 times 6. Then I have p squared times p. Remember that imaginary 1 right here. So when I add those, this is p to the third. I still need to finish distributing 8p squared, so I also need to multiply it by 2. 8 times 2 is 16. Since this does not have a p, the p squared stays the same. All right, I am done with 8p squared. It has been distributed. Moving on to minus 2. Be really careful. Whatever sign is here goes with the term that comes after it. So right now I am distributing a negative 2, not just 2. So negative 2 times 6p. Negative 2 times 6 is negative 12. The p stays the same. And then negative 2 times positive 2 is negative 4. As I look around, I've got a p to the third, p squared, regular p, and no p at all. So there are no like terms here. Nothing can be combined. Now, as I've said, I like to call this double distributing. Some people call this FOIL. So if you've heard that method before, you're welcome to use it. It stands for first, outside, inside, last. Because you multiply the first term from each parentheses, then the outside terms from each parentheses, then the inside terms from each, and then the last terms from each. So if acronyms help you, you're welcome to use it. I also happen to be wearing my foiling shirt today. It foils out the word plan. Ha ha ha. Okay. One more thing for the double distribute, and this is the main reason I don't use FOIL a whole lot, is because it only works when there are 2 terms in each parentheses. But what if I have 3 terms in the same parentheses? That could happen just like it did last week. That would look something like this. I've got 2 terms in there, 3 terms in there. Well, now we're just triple distributing. We don't need an acronym. We're just going to take every single thing in this parentheses and multiply it by every single thing in that one. So starting with 7k, I'll distribute it to all 3 terms in here. So 7k times k squared. Well, this one doesn't have a number up front, so it's technically a 1. 7 times 1 is still 7. K times k squared using exponent rules is k to the third. Move on to the next term in here. 7k times negative 2k. Don't forget about the minus signs. 7 times negative 2 is negative 14. K times k is k squared. Lastly, I need to multiply 7k by this positive 7 over here. 7 times 7 is positive 49, and I've got a k that I need to include. I am now done distributing this 7k because I multiplied it by every single thing in the other parentheses, which means I can move on to this minus 3. Again, don't forget about that sign. I'm first going to multiply minus 3 by k squared, so that's negative 3k squared. Now I have negative 3 times negative 2k. Negative 3 times negative 2 is positive 6, and I have a k to include as well. Lastly, negative 3 times positive 7 is negative 21. I've now distributed both of these terms by every single thing in the other parentheses, so I'm done distributing. However, I need to look for like terms. Let's just start at the beginning. 7k to the third. That's the only k to the third, so it is not going to change. This one is a k squared. There is another k squared down here, so those can be combined. Negative 14 minus 3 is negative 17, and the k squared part stays the same. Next is positive 49k. As I look at the rest of my terms, here's another k. So 49 plus 6 is positive 55, and the k stays the same. Lastly, I have a number with no k at all, so it doesn't have to change. This is everything I can do to distribute and then combine, and I'm done.